Hello and welcome to another short presentation by ZTE, part of the GSMA MWC Africa. My name is Abdessattar Sassi, and I will be talking about reducing emissions from radio networks and how is that important to the sustainable development of Africa. Over the next 10 minutes, we will understand why network energy efficiency matters, in particular for base station sites, and we will review what we are doing to improve it. Along the way, we will use some of the leading operators as examples and case studies. So let's start from the beginning. Climate change is a global challenge affecting everyone in every continent, including Africa. The Paris Agreement, adopted in 2015, aims to keep the global temperature rise this century well below 2 degrees Celsius. Finally, climate action is one of the 17 Sustainable Development Goals identified by the United Nations 6 years ago, leaving just 9 more years to cut emissions by 50%. Although the mobile industry is not one of the biggest emission producers, it plays an important role in the development of sustainable economies across the world. The GSMA and its members are committing to play their part in reducing emissions and to disclose their progress in a transparent way. We will look at a few highlights from 2 operator groups in the next pages. Our first example comes from Africa. In 2019, MTN signed up to the GSMA initiative to develop an industry-wide climate action roadmap in line with the Paris Agreement. While I encourage you to read the full report to gain a complete perspective of MTN's efforts for a sustainable development, I would like to highlight just one thing from it. A 2% increase in the number of base station sites came with a 14% increase in energy consumption and a 7% increase in emissions. On the positive side, the group has managed to reduce the carbon footprint per subscriber by 0.2%. This first example highlights the difficulty of the task, especially in Africa. Our second example is from Europe and is an amazing success story. During the last year, Vodafone reduced its total Scope 1 and 2 greenhouse gas emissions by 30% year on year. In addition to a special focus on energy efficiency, Vodafone increased the proportion of renewable electricity purchased in Europe from 33% in FY20 to 80% in FY21. Vodafone's energy use has remained broadly flat during the last year, despite a 47% increase in mobile data traffic over the same period. This is due to the use of more energy-efficient mobile technology and analytics, including massive MIMO, that is approximately 70% more efficient than older technologies. Now, if we look into energy use at Vodafone networks, we find a similar situation to what MTN already highlighted. 73% of energy is used at base station sites. We've already mentioned massive MIMO, and there are many more technologies, in particular with the 5G new radio, to achieve higher spectrum efficiency. I'm not going to go into the details of that. What I would like to do in the rest of this presentation is to focus on how to improve power management at base station sites. If we look at the typical traffic pattern in a radio site versus its energy use, without any optimization, we will see what is shown in this chart. Energy consumption does not closely follow the traffic pattern. In particular, at low traffic, the base station site still consumes a large amount of energy, and this can be optimized. We have identified 3 strategies for that. First, identify specific scenarios based on traffic modeling and forecasting and apply specific site configuration when these scenarios happen. Second, make acceptable compromises on KPIs to reduce energy consumption. The key here is to be able to power up or down at the lowest granularity possible, the symbol level. Third, optimize energy usage at a macro level by coordinating the service across radio access technologies such as 4G and 5G, frequency bands, and coverage types. ZTE has been working on a solution known as Power Pilot to implement these strategies. The first generation since 2008 introduced software-based power management features for the base station hardware, including partial shutdown and deep sleep capabilities. The second generation since 2019 introduced the power of AI. A centralized system collects data and analyzes it to produce the most suitable power-saving strategy for a particular base station site. The third and last generation takes optimization to the next level with handover and user redirection within the same radio access technology domain or between different domains such as 4G and 5G. In the next pages, we will review example implementation cases and the results they achieved. The first case comes to us from India and only uses the first generation solution. The energy saving function in the base station sites is only enabled between midnight and 6 a.m. and is customized on a layer-by-layer basis to take into account coverage continuity requirements. For example, the 1800 layer does not use any power saving feature because it is the one providing continuous coverage. This implementation case achieved 20% savings during the power management period, equivalent to 5% savings on the daily energy usage. Our second case uses the second generation AI-powered solution and comes to us from Indonesia. The scope of the optimization includes over 800 cells with various traffic models. Some of these sites do not use any power savings features, some others only use the basic ones, and the remaining use the AI-powered traffic analysis and forecasting to manage the power at the symbol, channel, and carrier levels. Overall, this implementation achieved an 8.4% saving. However, you can clearly see from the chart on the right that sites using AI had the best results. Our third and final case comes from China and uses the third generation of the solution, which provides the most comprehensive strategy: service awareness. The implementation is, as of today, a pilot with a scope of 10 sites providing both 4G and 5G services. In addition to the usual power management features, this implementation analyzes the KPIs and KQIs in the sites to automatically decide when it is appropriate to redirect the user from the 5G service to the 4G service in order to further reduce the base station's energy consumption. Notice that such redirection has no impact on the user's perception of the provided service, and therefore, the 5G logo on the handset is maintained as is. In addition to being used in radio networks across the world, ZTE Power Pilot has won several awards, including the latest innovation breakthrough in mobile technology from GTI in 2021. With this solution and others from ZTE, we aim to be doing our part to act now to stop the global warming. I hope you enjoyed this short presentation, and if you can only remember one thing from it, I'd like you to remember that in Africa, like in any other continent, energy usage in networks is driven by base station sites. While we still have a lot to do to improve the ratio of renewable energy in the African grids, we do have several technologies today that can cut power consumption at base station sites. Thank you.